Hello students, we are going to study formal charge today, okay? So, we had studied about electrovalent bond, covalent bond, coordinate bond, isn't it? Lewis dot structure, isn't it? Does this Lewis dot structure give the actual, tells about the actual shape of the molecule or that ion? No, it doesn't say, okay? It can't say about the actual shape, okay? So, in case of polyatomic ions on the molecules, okay, the net charge, okay, is on the whole ion, okay, not on a particular atom. So, if it is not on a particular atom, okay, it can't say about the shape, isn't it? So, we assign formal charge, we assign what? The formal charge on that atom, okay? And as the result, what is this formal charge? Formal charge is what? The polyatomic ions or molecules is the difference between the number of valence shell electrons of that ion in the isolated or free state and the electrons, number of electrons assigned to that atom in the Lewis structure. When I am saying isolated, what does this isolated means? It means what? Na plus. Okay, the ions we take it in isolated form. Okay, and if we are taking the molecule, it is in free state, like ozone. Okay, in free state. If I am saying isolated in the ionic form, like Na plus. Okay, so how do we take out this formal charge? Okay, formal charge is not taken as a whole. I can't say that take out the formal charge of ozone. No. Whenever I'll say find out the formal charge of oxygen present in the ozone, or the first oxygen present in the ozone, or the second oxygen present in the ozone. Okay, it defines that particular atom. Okay, that formal charge. So what is that? What is formal charge actually? What is the formula of formal charge? It is the valence electrons minus the lone pair electrons minus the half shared electrons. By this formula we can take out the formal charge of the ion or of the atom, okay, present in that particular what? Molecule. Okay, this I will be explaining you with the help of example. So, I said to you about formal charge. What is formal charge? How can it be calculated? Okay, now we are going to see with the help of what? An example. Okay, so here, okay, I have taken the example of ozone molecule. So can we calculate the formal charge of whole ozone together? No, I said to you, we take out the formal charge individually of each atom in the molecule. Okay, so here we will be assigning 1, 2 and 3, okay, to these all 3 oxygen atoms which forms the ozone molecule. Okay, now here, according to the Lewis dot structure, okay, the structure of ozone molecule is like this, forming what? Covalent bond. Okay, now here you can see what? When we have assigned it 1, 2, 3, 4, first oxygen we are going to take out the formal charge. Okay, a formal charge, first atom of oxygen. Okay, how many valence electrons are there in oxygen atom? 6, isn't it? Valence electrons are present. So in the first one, how many this free electrons, lone pair electrons are there? Only 2, isn't it? And yes, how many shared pairs of electrons are there? 1, 2, 3, 4, 5, 6. Okay, now just solve this. Okay, it becomes what? 6 minus 2, how much it becomes? 4, and 4 minus 3, it becomes 1. So what charge does this acquire now? Plus 1. Formal charge of this oxygen atom is plus 1. Now coming to the second, okay, here how many valence electrons of oxygen? 6, isn't it? And here how many lone pairs? 1, 2, 3, 4, isn't it? Minus half the shared electrons. How many electrons are shared over here? 1, 2, 3, 4. Okay, just solve this. Okay, how much will you get in this? In this 2, 6 minus 4 is 2, 2 minus 2, it becomes 0. Okay, so what charge does this acquire? 0. Okay, coming to the third oxygen atom. Okay, here formal charge to calculate it. How many valence electrons in oxygen? It is 6, isn't it? 6 minus the lone pair. Lone pair how many? 1, 2, 3, 4, 5, 6. Okay, 6 minus. How many shared pairs are there? Okay, 1, 2. Okay, so what you will do? Simplify it. Okay, so here what happens? Here it is 1 and here 6 minus 6 is 0. So answer comes what? Minus 1. So the charge acquired here is what? Minus 1. So this is having plus, okay, 1 charge. So you will be writing over here what? Plus. Here it is having minus 1 charge. You will be writing minus. Here 0. So nothing. So up till now we have seen what is formal charge and how this formal charge can be calculated. But what is the purpose of this formal charge? Okay, this formal charge actually it keeps the track of valence electron in the molecule. Okay, it keeps the track of what? The valence electrons in the molecules, how many are there. Okay, it also tells that which is having the lower energy. The atom which is having the lowest formal charge will have the lowest energy and thereby it will be more stable. So here we can see which is more stable. This one, because it is having what? The lowest formal charge, that is of minus 1. Okay. Now this whole molecule which we are seeing, it is what? A pure covalent view of bonding, okay, in which electron pairs are what? They are shared equally by the neighbors. Okay, here we are not seeing about what? The electrovalent bond. Okay, so this is all about formal charge. So we have studied about Lewis structure, Coastal approach, Lewis dot structure, formal charge. Okay, and what did we study in that? Yes, the last valence shell should have 8 electrons, its stability. Lewis structure, it said about the electrovalent bond, okay, and Coastal, he came and he and Coastal and Lewis together they said yes, electrovalent bond will be formed to be stable and to get 8 electrons in its last valence shell, that is the octet rule. But what happened later on? They saw that this is not fit for all. Then came Langmuir, okay, he said that yes, there is some other bonding called what? Covalent bonding, where sharing is being taking place, okay, and that was also accepted, and accordingly they were trying to study the shape of the molecule, okay, but they failed. It was only to the limited extent they could find anything, okay. Then came what? Formal charge, which we have right now studied, okay. We said that yes, if we are taking the particular atoms present in the molecule, yes, we can say the shape. But what happened? In that only we only could track the electrons, the valence electrons, and what? The lowest energy state, which we said that it is stable. Nothing more we could get, isn't it? So it means there is some limitations in this octet rule. Because of that they were not able to find anything. Okay. So yes, it was then totally declared yes, this octet rule is not fit for all the molecules to describe its shape. So as they could not explain the whole shape of that molecule, okay, it means there are some limitations in that octet rule. And what are the limitations we are going to study right now. Okay, so first limitation let us take, okay, the incomplete octet of the central atom. Okay, when we are saying incomplete octet of the central atom, it means the central atom 8 electrons are not present in its valence shell after forming the compound also. Okay, after forming the bonding also. Examples: lithium chloride, beryllium hydride and boron trichloride. Okay, see, here we are seeing what? This lithium is only having 2 electrons in its outermost shell. So does it, after forming the bond also, okay, so does it follow the octet rule? No, isn't it? Here also you can see this beryllium, the central atom, okay, it is having 2 valence electrons. After sharing it is only having 4, not 8. It means not following the octet rule. Like that, boron trichloride also boron. Okay, we all know how many electrons does boron have in its outermost shell? Only how many? 1, 2 and 3. Okay, and after 3 chlorine combines also and forms the bond also, how many electrons are there? Only 6, not 8. So here this compound we are finding what? This octet rule is not followed. But yes, these compounds exist. So here it is a limitation of octet rule. Now coming to the next, odd electron molecule. How are these odd electrons coming? When we are saying that yes, in the last valence shell it should be 8 electrons. And 8 is an even number, I think so, isn't it? So how does this odd electron molecule is formed? You can see in case of this, what? Nitrogen monoxide and nitrogen dioxide. Okay, just count it. For nitrogen, how many there are? 1, 2, 3, 4, 5, 6 and 7. It should be 8, isn't it? Why 7? And that too a odd number. Okay, next. Take this nitrogen, the central atom for nitrogen dioxide. Okay, how many are there in the valence shell before forming the bond? 5. Okay, that is here. And after forming the bond, how many there are? 1, 2, 3, 4, 5, 6, 7. Again, this is a limitation of octet rule. Now, expanded octet. What is this expanded octet? Here we are seeing that there is what? Insufficiency of electron to follow the octet rule. But here we are seeing more than 8 electrons present in the valence shell. Okay, more electrons are present. You can see of what? Here, PF5. I have shown you the structure over here. You can see over here, after forming the bond, this phosphorus is having 10 electrons. See, 5. Initially it was having, combining with 5 atoms of fluorine, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, octet rule is not followed. Okay. Now, we are saying what? These noble gases, yes, they are stable. They have 8 electrons in its outermost shell. No need to combine with any other and form bonds. But yes, there are compounds which are found which shows the bonding. So how this octet rule we can say by obtaining 8 electrons in its last valence shell, okay, they are stable. Okay, so this is also a limitation. Next, this octet rule could not say about the shape. They were trying that yes, from this we can say the shape, but no, it failed. Okay, next. It could not explain the relative stability of the molecules, being totally silent about the energy of the molecules. Okay, so they are not saying also basically how much stable it is. Okay, and about the energy also properly. Yes, they said yes, that yes, the lowest energy will have the formal charge. When we were calculating, we said that the lowest formal charge says about what? The lowest energy level, but it could not explain much. So here we got the limitation of this octet rule, and further we will be studying how different theories came which could explain what the shape of the molecule. So this is all for today. Good day, take care.